In this section, we are going to focus on why OEE is used in manufacturing and operations. In the previous section, we introduced what OEE means and how it is built from availability, performance, and quality. Now we are going to shift from the definition to the purpose. The key question for this section is, why should a manufacturing organization measure OEE in the first place? The answer is that OEE gives us a structured way to see where we are losing equipment effectiveness, production capacity, and good output. It helps convert what we often experience as general frustration on the shop floor into specific, measurable losses that can be prioritized and improved. Why OEE is used in manufacturing and operations. This section is about understanding the practical value of OEE. OEE is not used simply because it is a common manufacturing metric. It is used because it helps teams understand how well their equipment and processes are actually performing during scheduled production time. In many operations, people know that production is not performing as well as it should. They may know that the line feels unreliable, changeovers take too long, operators are fighting repeated minor stops, or quality issues are reducing output. But without a structured measurement system, those losses can remain unclear or subjective. OEE gives us a way to organize those losses. It helps us determine whether our biggest opportunity is related to downtime, running speed, or quality. That structure is what makes OEE useful. OEE makes equipment-related losses visible. OEE is used because it gives teams a clear and structured way to measure equipment-related losses. Without OEE, many losses are hidden, underestimated, or accepted as normal. For example, a machine may have frequent short stops throughout the shift. Each individual stop may only last a minute or two, so people may not see it as a major issue. But when those short stops are added together across a shift, a week, or a month, they can represent a significant loss of production capacity. The same thing can happen with slow running. If a line is designed or expected to run at a certain rate, but consistently runs below that rate, the line may still appear productive because it is running. However, it is not producing at its full potential. Quality losses can also be hidden. Scrap, rework, startup rejects, and defects all reduce the amount of good product produced from the available production time. Manufacturing teams often know they are losing time, capacity, or output, but they may not know exactly where the biggest losses are occurring. OEE helps identify whether the main problem is downtime, speed loss, or quality loss. That distinction is important because each type of loss requires a different type of response. A downtime issue may require maintenance support, reliability improvement, spare parts planning, or better troubleshooting. A speed loss issue may require process optimization, material review, operator training, or equipment adjustment. A quality loss issue may require root cause analysis, process control, inspection improvements, or corrective action. So the purpose of OEE is not only to calculate a percentage. The purpose is to make the losses visible enough that the team can take the right action. OEE helps teams ask the right questions. OEE is useful because it helps answer practical manufacturing questions. The first question is, are we losing more time from breakdowns or from changeovers? This matters because the improvement strategy would be different. If breakdowns are the largest loss, we may need to focus on preventive maintenance, equipment reliability, failure modes, spare parts, or maintenance response time. If changeovers are the largest loss, then we may need to focus on setup reduction, standard work, tooling readiness, cleaning practices, or SMED activities. The second question is, are we running slower than the equipment's standard speed? A line may be running, but still not performing well. Performance loss can come from reduced speed, unstable material flow, operator pacing, equipment limitations, jams, or repeated small interruptions. The third question is, are small stops adding up to a major loss? This is especially important because minor stops are often normalized. Operators may clear a jam, reset a sensor, or restart a machine many times during a shift. Each event may seem small, but the total impact can be large. The fourth question is, are defects reducing our true output? It is not enough to know how many units were produced. We need to know how many good units were produced the first time through the process. Scrap and rework consume machine time, labor, materials, and capacity. The final question is, which line, machine, shift, or product has the biggest opportunity for improvement? This is where OEE becomes useful for prioritization. Instead of guessing where to focus, the data can show us where the largest recurring losses are happening. In other words, OEE helps move the team from opinion-based problem solving to data-based problem solving. OEE creates a common language. OEE is also valuable because it creates a common language between production, maintenance, engineering, quality, and management. In many organizations, different departments describe the same problem in different ways. Production may say, "The line had a bad day." Maintenance may say, "The equipment was only down for one major issue." Quality may say, "The real problem was the amount of scrap." Management may say, "We missed the schedule." All of those statements may be true, but they are not specific enough to drive focused improvement. OEE gives the team a more precise way to describe what happened. Instead of saying, "The line had a bad day," the team can say, "Availability was low because we lost 90 minutes to unplanned downtime." Instead of saying, "The line was slow," the team can say, "Performance dropped because the line ran at 75% of standard speed." Instead of saying, "Quality was bad," the team can say, "Quality losses reduced good output by 4% due to defects and rework." That level of clarity matters because it helps the team align on the problem. When the loss is clearly defined, the right people can work on the right countermeasure. OEE also helps prevent finger pointing. The metric separates the loss categories so teams can look at the process objectively. The discussion becomes less about blame and more about understanding where the process failed and what needs to be improved. This is why OEE is powerful in daily management. It gives production, maintenance, engineering, quality, and leadership one shared view of equipment effectiveness. The key takeaway from this section is that OEE turns general complaints into measurable losses. Without OEE, we may know that a process is struggling, but we may not know whether the real issue is downtime, speed loss, quality loss, product mix, changeover time, or repeated minor stops. With OEE, we can separate those losses and quantify them. Once losses are measured, they can be prioritized. Once they are prioritized, they can be investigated. And once they are understood, they can be improved. So as we continue through the OEE training, remember that the value of OEE is not the score by itself. The value is in the conversation and action that the score creates. A good OEE system should help the team answer 3 basic questions. What did we lose? Why did we lose it? What are we going to do about it? That is why OEE is used in manufacturing and operations.